Tonight, when it gets dark, look up. The moon will be there, roughly the same size it's always been, doing the same quiet job it's done for over 4 billion years. You've never had to think about it. And that's exactly the problem, because the moon isn't decoration. It's infrastructure. And if it vanished tonight, you wouldn't just lose a light in the sky. You'd lose one of the last stable things holding your entire world together. Here's the reframe. You probably think of the moon as passive, a rock that reflects sunlight and occasionally looks pretty during a full moon. But the moon is doing physical work on this planet right now, every second, whether you notice it or not. Its gravity is quietly stabilizing something you depend on far more than moonlight, and the moment it disappears, that stability disappears with it. Let's start with the most immediate effect, the tides. Ocean tides are caused primarily by the moon's gravitational pull on Earth's water. Oceanographers have long established that the moon accounts for roughly 2/3 of the tidal force acting on Earth's oceans, with the sun contributing the remaining third. Remove the moon, and tides don't disappear entirely. The sun still pulls, but they shrink dramatically to roughly 1/3 of their current strength. That sounds like a minor inconvenience until you realize how much of Earth's ecosystem is built around that tidal rhythm. Coastal ecosystems, from mangrove forests to tidal marshes to the spawning cycles of countless fish species, are timed to those tidal swings. Marine biologists have documented that species from horseshoe crabs to coral rely on lunar and tidal cycles to synchronize reproduction. Weaken the tides suddenly, and you don't just calm the ocean. You disrupt reproductive timing for organisms that form the base of entire coastal food webs. But the tides are the visible effect. The real crisis is one you can't see, and it's happening in Earth's tilt. Here's where the video gets stranger than most people expect. Earth's axis is currently tilted at about 23.5 degrees, and that tilt is remarkably stable, varying by only about 1.3 degrees over tens of thousands of years. Astronomer Jacques Laskar and his colleagues ran long-term simulations of the solar system in the 1990s and found something unsettling. Without the moon's gravitational influence, Earth's axial tilt would become chaotic, potentially swinging by as much as 60 to 85 degrees over millions of years. The moon acts like a gyroscopic weight, stabilizing Earth wobble the way a spinning top stays upright with a heavy base. So picture what an unstable axial tilt actually means. Your seasons aren't determined by how close Earth is to the sun. They're determined by that 23.5 degree tilt. A stable tilt means predictable seasons, predictable climate zones, predictable growing seasons for agriculture across the entire planet. An unstable, wildly swinging tilt would mean regions that are currently temperate could become alternately scorched and frozen over geological timescales, not gradually and gently, but with the kind of instability that makes long-term climate, and therefore long-term agriculture, civilization, and species survival, dramatically harder to sustain. This wouldn't happen tomorrow. Laskar's simulations describe changes over millions of years. But it reveals something you didn't know you were relying on. A companion that's been quietly preventing planetary chaos since before complex life existed. Here's the counterintuitive twist. You'd expect losing your closest celestial neighbor to be purely a loss, but some scientists have pointed toward something stranger. Planetary scientists studying rogue planets and moonless worlds have noted that a moon-sized companion likely made Earth's environment more conducive to complex life in the first place, not just through tidal stability, but by potentially influencing the intensity and mixing of ocean currents, and by moderating the length of Earth's day itself. Tidal friction from the moon has been gradually slowing Earth's rotation for billions of years. Early Earth's days were dramatically shorter. Some estimates suggest as little as 6 hours, back when the moon orbited much closer. Remove the moon today and that slowing stops, but the current 24-hour day doesn't change instantly. What changes is the future you were heading toward. The moon has been a silent editor of your planet's entire timeline, not an observer of it. Now here's where this stops being about rocks and orbits and starts being about you specifically. Consider what disappears from human experience, not just from Earth's physics. For nearly the entirety of human history, before electric light, before street lamps, the moon was your species' primary source of usable light after dark. Anthropologists and historians studying pre-industrial societies have noted that human activity, travel, hunting, social gatherings, was often structured around lunar phases, because a full moon meant you could actually see where you were going. The moon didn't just illuminate your ancestors' nights. It shaped when they worked, when they traveled, when they gathered, and even how early human calendars were constructed, since many of the earliest known calendar systems were lunar, tracking months by the moon's roughly 29.5-day cycle rather than the sun's year. This is where the mirror comes in. You don't think about the moon's absence because you've never experienced it, the same way you don't think about the specific, quiet forms of stability in your own life until they're gone. The moon is exactly the kind of thing your brain has learned to filter out because it has never once failed to be there. Psychologists who study risk perception have long noted that humans are remarkably bad at valuing stable, ever-present things, and remarkably good at panicking over sudden, novel threats. A friend who has shown up for you reliably for 15 years registers less emotionally in the moment than a single dramatic betrayal, even though the 15 years of consistency represents vastly more real support. Stability is invisible specifically because it's stable. You only see the shape of what's holding you up once it's gone. So bring it back to your actual life. What's the moon in your world, the thing so reliably present that you've stopped consciously registering its value? It might be a person who checks in on you without being asked. It might be a routine you've built your stability around without noticing you built it. It might be your own health, quietly stable until the day it isn't. The moon's disappearance wouldn't announce itself as a single dramatic event to most people. At first, the sky would just look a little different. The real damage would unfold slowly, in tidal rhythms disrupted, ecosystems destabilized, timelines shifted. The way most real damage in your life doesn't happen through one obvious event either. It happens through the slow withdrawal of things you assumed were permanent. So what if the moon disappeared? Earth wouldn't end immediately. Life would adapt, the way life almost always eventually does. But something ancient and load-bearing would be gone, a piece of infrastructure so old and so consistent that 4 billion years of evolution, and every human calendar, tide chart, and quiet night walk was built assuming it would always be there. Tonight, when you look up and see it exactly where it's supposed to be, that's not nothing. That's one of the oldest, steadiest relationships your entire planet has ever had, still holding, still working, still going completely unnoticed.